Hi guys, so today we are going to work on parabolas. We are going to continue with our chapter on conic sections. This is 11.3 that we are going to do, and it is parabolas. Now parabolas are not new to you, right? It's a familiar shape. We have done parabolas in math 2, and at that time we stressed on the algebra of the parabolas. You all know the shape of the parabola. It's either like this or like this. And what was the equation? The standard equation of the parent function? It was y equals x square, which means y is raised to 1, right? So y is linear and this is, the power is 2, so this is a quadratic. Okay, today in this pre-calculus we are going to look at parabolas which open this way or this way. Okay, no need to worry about it. It is quite straightforward. We are going to focus on not on the algebra so much, but we are going to focus on the graphing. So now there are two terms, new terms here in parabolas: focus and directrix. Before that, let's quickly review what ellipses were and what hyperbolas were. Remember what are ellipses? There are 2 points, and we are looking at a collection of all such points which every point here, the distance of this point to the first point and the distance of this same point to this point, whatever is the sum of this distance, it's going to be the same. So if this plus this is something, okay, and then I take the next point. Again, from that point, the distance to this point and the distance to this point, the sum of this will be the same as the sum of this. And this forms an ellipse. Okay, so if these are my 2 points, there will be an ellipse like this around it. So every point on the ellipse, distance from to the first point and distance to the second point, this plus this will be the same as this plus this, will be the same as this plus this, will be the same as this plus this. This is what forms an ellipse. What was a hyperbola? Again, there are 2 points, and we are looking at all such points such that if I take the distance from this point here and this point here, the difference, bigger distance minus smaller distance, the difference is going to be the same. So this is how I get my hyperbola. So this is a point and this is a point. Okay, so the distance of every point from these 2 points, the difference will be the same. So that's an ellipse and a hyperbola. Today we are going to look at parabolas, and in parabola there are 2 things. We don't have 2 points, we have 1 point and a line. Okay, so what I'm going to look at is the distance of the point on the parabola. Every point on the parabola, the distance, if I take this point on the parabola, this distance from this point that we started with and this distance towards the line, that distance will be the same. Now before we continue, let me just remind you, what does it mean to find the distance from a point to a line? So how far is this point from the line? I am not going to calculate this distance or this distance. Always the distance means always the perpendicular distance. So whenever you are asking how far is the point from the line, you always calculate a perpendicular from that point to the line. There can be only one perpendicular, right, from a point to a line. So this is the distance from the point to the line. So now when I have my parabola, this is what I'm looking at. Suppose I take this point. Then the distance of this point to this point and the distance from this point to this point, this distance will be the same. This distance will be the same. Okay, it will not, this distance has nothing to do with this distance, right? It's just that this and this will be same, this and this will be same. If I take another point here, distance to the line, which is a perpendicular distance, and distance to the point. This distance will be the same. So no matter what point I take on the parabola, there will be a fixed point. This point is called as the focus. Okay, so this fixed point is the focus. And there is a line which is called as the directrix. Okay, focus is a point, directrix is a line. So the distance on the parabola, the distance every point on the parabola, it will have the same distance from the focus and same distance from the directrix. Make sense? Let me just check and make sure you can see this well. Yeah. Okay. Oh, my spelling is wrong. It is directrix. Okay. So the focus and the directrix, it has to be the same distance. So these are new terms when we did 1 minute, let me just adjust this better. Okay, yeah, this is better, I think. So the focus is a point, directrix is a line. Every point on the parabola will be equidistant from the focus and the directrix. Okay, so now let's look at the equation. So now we talked about, we are on page 710. I'm not going to go too much detailed into this parabolas. We'll just do based on what our textbook requires us to do. So now there can be two types of parabolas. Either your parabola is going to face up or down, right? This is what we are used to. Either like this or it will be like this. Okay, so this is up or down, and the other one is facing to the, opening to the left, opening to the right. Okay, remember the parabola will only be one of these, either this or this. This is not like the hyperbola where there are two portions. Either it's this or this or this. Okay, now this is your familiar parabola which was y equals x square, right? So the quadratic is x, y is the linear term. What happens in the sideways parabola? It's the other way round. X equals y square. The linear is x and y is the quadratic. So in this case, we will look at this parabola with respect to the focus and directrix. When we did this in math 2, when we did quadratics, looking at the equation, there was no way, we did not even talk about what the focus can be, what can the directrix be. But now we are going to focus on that. So there is a standard formula. The formula is y equals x square over 4p. Remember this. If I write this as y equals x square over 4p, then my focus is going to be what? So in this case, where is the focus going to be? Suppose I have this parabola. Okay, where is the focus going to be? Somewhere here. The focus is not going to be on the parabola, and there is going to be a directrix. So this is my directrix and this is my focus. Let me write it as D because this is a line. Okay, the directrix also does not touch the parabola. The focus also does not touch the parabola. Okay, so if this is my case, looking at the equation, what can I say? The focus, obviously it lies on the y-axis. Remember, on the y-axis, every x coordinate is 0. 0, 0, 0, 1, 0, 2, 0, 3, 0, negative 100, 0, negative 1000. So the equation of the y-axis is x is 0. So this focus, the point, we are going to call it as, obviously the x is 0 and the y coordinate, we call it as p. So if I am given an equation, automatically based on the equation, I know what is p. P is 0p. Okay, and what did we say? Every point on the parabola is the same distance from the focus and from the directrix, which means this point, remember what did we call it in our quadratics? We called it as the vertex. So in this case, this distance will be equal to this distance, right? So if this is P, what will this be? This will be negative P. This is a horizontal line. What's the equation of the x-axis? Every y coordinate on the x-axis is 0. 0, 0, 1, 0, 2, 0, negative 10, 0. So the equation of the x-axis is y is 0. Which means what is the equation of the directrix? It's going to be y equals something. Every point on this line will have y as negative p. Okay? So this is 0 negative p, this is 1 negative p, 2 negative p, 3 negative p. So the equation of this line is y equals negative p. Make sense? This is all there is to it. So if there is an equation y equals x square, we are going to write it in this format. Y equals x square over 4p. So suppose I take this parabola now. Y equals x square. What does this mean? It means it's y equals x square over 4 times what? Now what is this x square equal to? This x square is just x square, right? So this was my original equation, y equals x square. I want to make it look as if it's y equals x square over 4. This is actually y equals x square. So this is y equals x square over 1. But I want to write it as x square over 4 times something. Now 4 times what will give me 1? 4 times 1/4. Right? Why am I writing it in this format? Because when it is in this format, I know my P is equal to 1/4. Right? I get P equals 1/4. Which means what is my focus going to be? Now since you have to always keep in mind, this parabola is opening up and down. So what's the focus going to be? It's going to be on the y-axis, which means x has to be 0. The focus is 0, P. So the focus is 0, 1/4. So this point here is 1/4. What about the directrix? Directrix is a line. So either it will be x equals something or y equals something. In this case, it's a horizontal line. It's parallel to the x-axis, which means it's going to be y equals something. What did we say it is equal to? Negative p. In this case, our p is 1/4. So negative 1/4. Make sense? Same thing for this equation. Okay, so let's look at this equation. The equation of this line is x equals y square. The vertex of the parabola will always be in between the focus. The focus will be somewhere here, and the directrix. Here the directrix was horizontal. Now my directrix is going to be vertical. One thing I know for sure, this is my y-axis. Equation is x equals 0, which means the equation of the directrix, all vertical lines, is x equals something. This is the focus. It lies on the x-axis. The x-axis is y is 0. So no matter what point I take, the y coordinate will be 0. So it's something 0. Okay? And what is this and this? Thankfully, it's just the same thing. This will always be just P, and the directrix will be whatever is P, negative. It makes sense, right? Because this is on this side. The focus is always inside the parabola. Since the parabola is opening there, the focus has to be positive, P. And the directrix is on the opposite direction. So if this is positive, this is negative, right? So here in this case, I know the equation is x equals y square. But in case if I want to find the directrix, my directrix and focus, I need to find the P. What's the relation of P? P is always x equals y square over 4p. In this case, x equals y square means it's y square over 1. Right? So same thing. Which means 4p equals 1. I showed this same thing in a different way. I'm showing this in a different way. Choose whichever way makes more sense. How to find the p. So this is 4p equals 1, which means p equals what? 1/4. See, I got the same thing. But this p equals 1/4, when I'm finding the focus, I know it's on the x-axis, so I know my y is 0. It's 1/4, 0. Right? Here it was 0, 1/4. What's the directrix? The directrix is a line. It's either going to be horizontal, in which case the equation is always y equals something, or it will be vertical, which means the equation is x equals something. Since the parabola is opening sideways, its directrix has to be vertical, which means it's going to be x equals. It's going to be the same distance away from the focus. So if p, this is p, it was p units to the right, now it's p units to the left. So it's x equals negative p, which says it's x equals negative 1/4. Is that making sense? Okay. I like the way they have explained stuff on page 710 and 11. Okay. Make sure you have your textbooks open while you are doing this. Okay. Let me go over 710 and 711 so it will make more sense to you. So I'm on page 710 right now. Okay. They are talking about the note, under the note. See, one of the variables is quadratic and the other variable is linear. So when your parabola is either up or maybe down, okay, the y, which means our familiar one, right, either facing up or opening down, one of these. It's the familiar one, y equals x square over 4p. Okay, if it is up, what is it going to look like? It's going to look like this, which means your p is going to be here. Your focus is going to be what? On the y-axis. The focus is on the y-axis. On the y-axis, every x is 0. Okay? And whatever is this is p. So just looking at the equation, you will get to know what is your p, that is your focus. Okay, you have to put your equation in this form, x square over 4 times something. You have to manipulate it so that it comes in this form. We'll do examples, it will make more sense. So this is focus is 0p. Okay, the p is right here. And what is the directrix going to be? Since this parabola is opening up, my directrix is going to be horizontal. Every horizontal line, just like the x-axis, y is 0. So every horizontal line will have equation y equals something. And it will always be, since this is p, it's p units down. So it will be negative p. Make sense? On the other hand, if it's a down facing parabola, it's going to look like this. The focus is going to be here and the directrix is going to be here. So this is negative. So this focus will be 0, negative p, and the directrix will be y equals, it will be a positive number. Let's look here. But remember, this is not the right way to tell you because p is p. P can be positive or negative. So this is really, don't get confused by this. P is a number. So I would rather, give you an example of a number. So in this case, okay, if my equation is y equals 8, x square over 8, which means what is p? X square is x square. Up it has to be 1, right? 1x square. 4p is 8, which means p is 2. Which means if p is 2, right, it's 0, 2. This is y equals negative 2. In this case, your equation will be what? In this case, your p will be negative. So your equation will be x square over negative 8. So your P is negative 2. So your focus is always 0 P. So 0, wait, let me make it a little here so it will make more sense. So y equals, what did I say? X square over 8. Okay, so x square over 8. The equation should be x square over 4 times what? It is 2, which means my P is 2. So if P is 2, it means 2 is here and this is negative 2. So this is 0, 2, y equals negative 2. Or my equation can be y equals x square over negative 8. I'm always asking myself, x square over 4 times what? Whatever it is 4 times, that will be the P. So in this case, to get the negative 8, I'm doing 4 times negative 2, which means P is negative 2. So whenever P is negative, I should know my parabola is facing down. Whenever P is positive, I should know my parabola is facing up. So now when I have the equation, I know my parabola is facing down. P gives me the focus. My focus is always 0, P. So this tells me my focus is 0, negative 2. And my directrix is, in this case, it's a horizontal line. So it's y equals negative P. So y equals negative of, what is P? Negative 2. So y equals 2, which is the positive line here. Y equals 2. Make sense? Let's look at the left and right. Let me check. Can you see? Yeah. Okay. So now let's look at the left and right. If it's left and right. One thing I know for sure when it's left or right was, here my y is linear, x is quadratic. In this case, my x is linear and my y is quadratic. Okay? So in both cases, I'm looking at x equals y square over 4p. This is for both cases. Okay, I'm asking myself, it's y square over 4p. So now if I'm given the equation x equals y square over, let's take the same one so you see the difference, over 8. What is y square over 8? It's as good as y square over 4 times 2. So whatever is 4 times, which means p is 2. So this is positive here, right? So it's 4 times. So I know my P is positive. When P is positive, I should know it is opening to the right. So let me write it properly. Right and left. Okay, so P is 2, which means on my graph, now since this is opening left or right, either left or right. So you should always know the symmetry. This is symmetrical on the y-axis, right? It is symmetrical on the y-axis, which means where is the focus? It's going to be like this or like this. So this focus is going to be on the x-axis, right? The focus is on the x-axis. So what is this point? It is going to be 2, 0. On the x-axis, every y-coordinate is 0. So the focus is what? Always it is P, whatever is P, and y is 0. In this case, P is 2, so it's 2, 0. And my parabola is opening right. Where will my directrix be? Same distance. This is the vertex from the focus, same vertex to the directrix. So if this is 2, this will be negative 2. So my directrix is a vertical line. Since it's a vertical line, I know my equation has to be x equals something. And just like this, Directrix is negative, right? Always, whatever is P, directrix is negative. So it's X equals negative P. So here I will write negative, then I'll go looking for the P. P is just 2. So this is the equation of the line. X is negative 2. Okay. Let's look at the last case. Let me use a different color. The last case is again X equals y square over negative 8. So by now you should know whenever it's negative, it's either to the left or it's down. Positive, right or up. So this is X equals y square over negative 8. The minute I see y is quadratic, I know it's left or right. And this is negative. So out of that, out of left and right, it is the left one. But how can I think about this? I write it as y square over 4 times what? Negative 8 means it's 4 times negative 2. Which means my P is negative 2. Right? So on this, I know my P has to be here. The focus is here. Once the focus is here, now we are not talking about parabolas which can be somewhere here. We are talking only about parabolas whose vertex is at the origin. Okay, we are not going too much into the complicated cases. We are talking only about parabolas with vertex on the origin. So if the vertex has to be here and focus is here, focus is always inside the parabola, right? So how can my parabola be here? No, it has to be like this, right? Which means whatever is this distance, some distance away, this will be my directrix. You need to know your opening and you need to know your equations of horizontal and vertical lines. So this focus is on the x-axis, which means all y's are 0, right? So the focus is always P0. Don't think about P as positive P and negative P. Focus is always P. But P is what? Negative 2. So my focus is negative 2, 0. And what's my directrix? My directrix is a vertical line. All vertical lines are x equals negative P. All vertical lines are x equals negative P. But in this case, I first write my x and then I write my negative. And what is P? P is negative 2. So negative negative gives me positive 2. See, the equation is here, positive 2. Make sense? See if you can see this. Oh, not able to see this. Okay. So what I did here was, I wrote x equals y square. This is the equation given to me. I always find what is this denominator, 4 times what? Whatever it is, this is my P. Okay, and then P is negative 2. And then you can go back and you can write down focus is always going to be P0 and x equals negative P is your directrix. So plug in your P, plug in your negative P. Okay. Next time I'll not go to the right so much. So this is more or less what they are saying is on 710, and I really like the table that they have on 711. It's a very neat table. I like it. So the table is what we talked about just now. So the basic things we know is this x square equals 4py. Now they are giving it in this term. How did we write it? We said y, the linear term, we set it by itself, right? So I can do this as x square over 4p equals y. I divide this by 4p or I divide this by 4p. Get used to both the terms. Your basic idea is there should be one quadratic and one linear. Okay, so either you can solve for the quadratic or you can solve for the linear. But if you solve for the linear, your p, you'll get it right there. So if this is my P, if P is positive, first of all identify this. Y is linear, X is coordinate, which means either it's up or down. Since P is positive, out of these two, which one? It's going to be the facing up. So when it's facing up like this, what's the focus going to be? Always your vertex is at the origin. Your focus will be here. So this is my P. It's the y-axis. So my x is 0. What is the directrix going to be? Now my directrix I know is the horizontal line. All horizontal lines are y equals something. So y equals negative P. This P and this is negative P because they are equidistant. The vertex lies right in the center of the focus and the directrix. Same thing now if P is negative. Okay, if I have x square equals negative 4py, I can also write it as y equals x square over negative 4p. So now since P is negative, what do I know? One thing for sure, x square is quadratic, which means it's either up or down. But this negative tells me it is down, right? The negative tells me it's facing down. So which means the focus will be where? The focus will now be whatever is the number. It will be negative something and this will be positive. Let's look at this. Y square equals 4px. Now x is linear, y is quadratic. This tells me it's a left or a right one. I can solve for x. It will be y square over 4p. Okay? Either it's left or right. The positive 4, this positive tells me it is a right one because P is positive. So since it's right and the vertex is here, it's going to look like this. Which means where is the focus going to be? This is the focus. It's going to be 0p. In this case, it's the x-axis, right? On the x-axis, every y is a 0. So P 0. What's the directrix? The directrix is vertical. So it's going to be the equation of the y-axis is x equals something. So the directrix is also x equals something. What? Negative P. Okay? If my equation is here, y square equals negative 4px, right? I can also write it as x equals y square over negative 4p. This negative tells me, see this y square tells me it's left or right. And this negative tells me out of that left or right, it is the left one. So this is going to be my focus here. This is going to be my directrix. Okay. In this case, my P will be negative and negative P, negative of negative, will give me a positive number there. Okay. So let's stop the video here and we will do the problems in the next video. Okay. Thank you.